let's have a recap what we've done. I've shown you, first of all, can we have a big cheer for President Trump, who, with all his silly ideas, has opened up enormous opportunities for people in China and Morocco and anywhere that isn't America. I've shown you how simple image recognition is and how simple the tools are that come with it. And I was going to show you a demonstration on my device here, but for some reason or other, something has gone wrong, either when it went through customs and the X-ray reprogrammed the machine, or I might have a failure. So we can't have a demonstration of ImageNet recognizing apples and oranges, cats and dogs, and things like that. But we will have the next time I come with a development kit. This shows us detecting bottles of Coke, dogs, people with luggage, people as pedestrians, facial recognition, and just general object detection. So we'll start now and we'll talk about the use of intelligent cameras in smart cities and how all this technology makes things so easy and so valuable. And as I explained to you in the last session, the salary for people who know about these things is about $250,000 a year, if you can get a visa, if Mr. Trump lets you in. If not, we'll have to do it here. Okay? This is a very simple and inaccurate layered model of a smart city as a complex adaptive system. As you can see, there are a number of different layers, from the topology environmental layer, fixed infrastructure layer, the flow layer, which is all about traffic and people and electricity and water, the economic and trade layer, and the political and social layer, and they all interact with each other. Now, this was the subject of a Horizon 2020. Do you know the Horizon 2020 project? Horizon 2020 is an advanced research project run by the European Union. If you can participate in it, it's good. This is the project from a few years ago, which is about the Madrid bus company trying to make their network more efficient. It used a complex event processor to process reports from sensors all over the city, but the sensors were very simple sensors, like counting traffic with wires in the street and things like that. But the architecture can be applied, the same architecture that's used there for real-time reporting of events can be applied to very many industries. And as you can see, it also applies to the use of smart cameras. Now, if you upgrade the sensors for a smart city from being very simple wires in the street to count cars going past to sophisticated cameras, you can analyze what is happening in the traffic jams and report that back to the city center. So you can count the number of cars, you can see whether there's been an accident, you can see if you can identify the cause of the fault, and you can analyze images like that. Now, if you learn how to do that, you will be able to set up a consultancy which can sell to cities all around the world, including Casablanca, which I believe has got some of the best traffic jams in the world. They're nothing like the really good ones where in Moscow, if a policeman puts his hand up like that, the whole city comes to a halt and it can take you 6 hours to get to the airport. Like in Nigeria, where they built a 6-lane highway around Lagos, and on the first day it was open, it became a traffic jam. It became a car park. So that's where we're at. So now the great thing about the technology, which I would have demonstrated to you if my machine worked, there's a special Greek god who's in charge of making sure that whatever demonstration you do in front of a live audience, it never works. What you can do is you can segment an image so that you can identify that it's a white truck, because you've got lots and lots of pictures of a white truck, and you can add that as a caption to the image. So that instead of having to send a photograph with all the content that's in it, you just send this text message, which reduces the bandwidth, and because it can be processed in natural language processing, you can use summarization techniques to provide an overall description of the status of the city in natural language, in real time. So that's captioning, and it's because we can analyze the content of the image. Now that again is something that we need a lot of people to work on generating the captions. But once we have a database of pictures with captions, it is very, very powerful. Natural language processing. This is my friend Diana's research group at University of Sheffield. She taught here last year, but we couldn't get anybody to come to the course. People who know about that are well paid as well. Now, graph processing at scale. Because we have enormous amounts of computing power and enormous amounts of storage on the cloud, we can generate a graph of every journey that somebody is doing in a city. Because we'll know where the vehicles are going when they start, because people will program it into their navigator, we can optimize their journeys so that they don't join traffic jams, they don't go a long way around, they go the most direct route, and if there's a traffic jam, if there's a crash, we can automatically figure out where the vehicles are, where they're going, reprogram the whole city's GPS navigators and send them a new route. So instead of having dumb GPS navigators, you can have intelligent GPS navigators so that cars from 50 meters back will not join the traffic jam. They will go a side street and go another way around. So that is a PhD project for somebody. There was a young lady was telling me that this is something that she's studying, but she had to head off to do something else. So we'll see where that goes. Now that is something that can be sold to companies and countries and cities all around the world. So we might be looking at a little company that we can start here in NCS Valley that will update things like this. Come on. God, technology. All right then. Metropolis is the name of NVIDIA's intelligent camera program, which presupposes that we would network 100,000 cameras in a city together so that they can all report in to a central organization in the city that makes traffic flow better and that will help catch thieves and all sorts of other things. We'll also be able to detect failures in the water system, failures in the electricity system. It can all be done with the tools that I've shown you so far. Okay, let me stand closer to this PC. Good. So we have moved on from smart cities and networks of intelligent cameras. I've shown you where to find the basic information that's been derived from the Horizon 2020 program, there are lots and lots of little companies that can be started which know about these things. However, we can also do things in the factory. Smart factories are changing the way manufacturing is done, because there is no point in having people lifting and carrying, walking down long aisles to climb up ladders to find things to take out to the counter in the front, to give them to somebody or to package them for posting. What you do is you use robots. And robots can not only pick things out of a box, put things in other boxes, but they can also fetch and set up production lines. Now, this is a very new science. There are only a small number of large companies which know how to do this. And we can train people in Morocco in the basics of the science so that they can get very good jobs with some interesting companies. And it all runs on the same processor as I was proposing for the intelligent cars. So, any questions so far? How many people still want to earn $250,000 a year? Nobody. That's what the price of somebody who knows a lot about all these things is. Okay? So for $250,000 a year, what kind of a house can you get? Nice house by the sea? Yeah? Okay, so these are the different kinds of robot we can have. We can have a flying robot. And if you want to know how to program a flying robot, Coursera have a very good series of tutorials online which tell you how to do the thing, give you guides to how to generate the software to make a helicopter fly, and you can program it straight into a robot. We have terrestrial robots which run on wheels. We have all-terrain robots which will go across rough country. Now, this is useful for mining companies. It's also useful because they can go through minefields, so that if the Al-Qaeda guys or the ISIS guys have been around and left landmines behind, you can send a vehicle across the minefield to find out where the mines are. You can have a marine robot which will go and inspect. It will inspect things, and it will also deliver things to the seashore. You can have a software robot which goes and finds its way through networks, and you can have a pick and place robot which picks up things from one box and puts them in another box. All very simple. Everybody's heard about all this before. Now, if you want to teach yourself robotics, I mentioned Coursera. And Coursera are an American organization, but for $50 you can get a basic course in robotics. When you've completed the course, you get a certificate and you know quite a lot about robotics. Probably enough to get you into a development team. Okay? So it talks about robot flight, robot movement, robot perception, which brings us back to robots with vision and how they adjust their movements, navigate difficult terrain, and accomplish complex tasks such as construction and disaster recovery. 3 months ago, there was an announcement of a robot which climbs over building sites to report on the progress on construction projects. So it climbs upstairs, walks along outside the floors of a house that's being built, and it reports back the progress with pictures. That's Coursera. It's cheap, it's good. Coursera courses are good. edX courses are good. And if you can't afford it, you can use FutureLearn, who let you attend the course free, but charge you £50 for their certificate. Okay? The robotics tasks that you have to learn include movement, steering. You've got to be able to steer the car so it doesn't go off to that side or that side, and you've got to keep making corrections. Collision avoidance. What can I see in front of me? Is it coming my way? Am I going to hit it? And what way am I going to go around it? Path following. Where am I going to go? Am I staying in the middle of the lane? Route finding. How do I go from A to B? Obstacle avoidance, again. Signage obedience. There's a nice book on reading traffic signs that you can buy from Amazon. It's only £50. A book on grasping. Picking things up and grasping things is a difficult task. You need different hands for different tasks. The hand that you'll use for picking up a part of a car is very different to the hand you will use if you're picking strawberries. So I'll show you some videos of these. You'll be able to lift things. So you've got to have a good grasp of what you're trying to lift so it doesn't drop. And you've got to be able to place it down. If you're picking apples, you've got to be able to put the apple down gently so you don't bruise it. Otherwise, it'll rot. Now, here are some reference platforms, all of which include this device over here, which for some reason or other won't work for me in Morocco. It was working in England before I came here. But you've got a simple robot, you've got a flying robot, you've got an all-terrain robot, you've got a marine robot, which will go and inspect. It will go and inspect infrastructure along the coast. You've got a race car, and you've got another flying robot. Now, I think we should watch some videos. Does anybody want to watch some videos and see what adding vision to a robot really does? Right, let's try that then. Now, Murphy's Law says that when you try and do these things, they never work. Especially that one. No. If this works, This is about putting sausages in bags. And this is about automated food production and the use of robots with vision. These are the sausages as they're produced. As you can see, they're coming down onto the production line in all sorts of configurations, lying at different angles, and they would be difficult to get into a package as they stand. And here are the robots, and they're picking up the sausages from whatever angle they're lying on the conveyor belt, and they're putting them into empty slots on the other conveyor belt. And this is all driven by video robots. Now, if you can learn how to program those, there are some very good jobs for people. Now, do you see the speed that they're working at? That's a lot faster than a human can work, person can work. So it's very efficient, very cost effective. You see, he waits until he can find an empty space to put the sausages into. Now, what this does, automatic food processing like this, it eliminates waste, it reduces price, and it helps with feeding. It helps with feeding the 9 billion. Okay, so that also applies. This is putting biscuits in boxes. Now, these are very high-skilled jobs to fit this into a business model, because you have to justify the cost of the robot and manage the effect on the sale price. But if somebody has to compete against a robotized production solution like this, it's very difficult to make it happen if all the workforce is people. You see, the intelligent robot is waiting for a slot to put things into. These are chocolate bars. Let's see what else I can find. Okay, we've seen this. Now this is particularly important. This video is particularly important. Everybody knows that in England they are having a particular form of madness called Brexit. One of the problems with Brexit is that they can't get the people to come in and work in the farms picking fruit because they can't get visas to come from Romania and Bulgaria and places like that. So the farmers are finding that they are growing apples and vegetables, and because there's nobody to pick them, the crops are rotting in the fields. Now this is a machine which will automatically weed the space between plants, and it will come and pick. The plants, and we should also see an apple harvester which goes round, grasps the apple, pulls it off the tree. Now this is bad news for people who come from Mexico to California. But these machines are being generated. This is that's the kind of thing. I'll play that again. So you can see the thing picking apple trees.
Arrives with Professor Salah Sukaria and his team from the Australian Centre for Field Robotics.
Should we get the bot out? Yeah, sure.
Now you can read about this from University of Sydney and play catch up. But here is a device for picking apples. It ducks under the low branches of the trees. It sees the apple, checks whether it's ripe enough, then it very gently picks the apple. And this is all simple robotics with vision. And this is going and it's weeding the area between the plants, and it will be able to tell when the plants are ready, when the lettuce is ready to be picked, and go on from there. Now, has anybody here Yep. Has anybody here ever picked strawberries? It was my introduction to hard work when I was 16, because they used to grow lots and lots of strawberries for jam on big farms near where I lived, on the ground. So to pick the strawberries, you crawled along on your hands and knees all day, dragging a basket behind you, putting the strawberries in by hand. But here's a machine which picks strawberries. Instead of growing the strawberries on the ground, you grow them on raised beds so that the strawberries hang over the side. And then you have a special hand which is just firm enough to pick the strawberry without damaging it. Now that in itself is a science. It's called haptics. And here are the machines. What this does, and what all these robotics videos do, is they change the economics of production. Because to grow things, you need water, you need sunshine, and you need people to pick it. If you don't need the people, you can grow things in places where you've just got sunshine and water, but you don't need to bring people in from 100 kilometers away to pick things, which means that you don't need to bring people in from Mexico, you don't need to bring people in from Eastern Europe, And it is good news for people who want low food prices, but it's not good news for people who do simple jobs like picking strawberries. Unfortunately, it's one of the problems and dilemmas that we have to deal with. Okay, so let's look at.
Time is of the essence.
Now,
Quality. The system worked well when farm labor was cheap and plentiful. No longer. A tightening of the U.S. border with Mexico, combined with an improving U.S. economy and other factors, means strawberry growers and other produce farmers are struggling to find enough farm hands. Nathan Dorn, who works for a major supplier to Driscoll's, has witnessed the impact of labor shortages.
Every year it becomes more
come
difficult
on.
to find the people to pick our berries in the field. And if we don't have those people available, the fruit is perishable, and we have only a certain amount of time to get it from the field to the consumer. Last year there were millions of dollars of produce left in the field, unable to be harvested because there weren't enough people.
Juan Bravo is among those developing.
This is how Amazon stores its produce and gets it to you the same day you order it. These are robot machines. The sensors in the floor tell the robot where it is and tells the rest of the control system where it is. So you give the robot instructions, go and find the stuff that's at that rack in that row. It picks it up and moves it over to somebody who will pick the stuff out of the boxes. Now these are enormous stores. Because they don't need a lot of people, they can be best situated in places where there's cheap electricity, cheap water, and cheap real estate. That might be called Morocco, because you've got cheap electricity and you've got some good rivers.
It's expensive. It's expensive.
Well, the solar electricity, Usazarte, have a look at the prices of the electricity that comes from Usazarte. Okay? So this is how Amazon works. Now, if you want, one of the little courses that we can organize for you very cheaply will be a robotics course, which will involve building a model warehouse like this. Okay, and you learn all the skills to make this happen. Now you can start and you can build businesses which ship to all parts of West Africa from Morocco. So you would put the warehouse outside Tangier, you would bring the stuff in containers, you would unpack it into boxes, you would set up conveyor belts, and you would have a series of airlines shipping the stuff out. But this is what happens in an Amazon warehouse. The problem with an Amazon warehouse is that if you have to put people in, the Amazon people don't recognize that people have needs, that they need to take breaks, they need to go to the toilet. So the whole production line can break down if somebody needs to take a break to go to the toilet. So, is that something you think that people might like to learn? No? Everybody asleep? Bored to death? Do you think people might like to learn those skills? and set up consultancy here in Morocco? Why should the Swiss be the only ones that know how to do this? You can learn. I'm happy to help teach you if you want to. So let us run the slideshow from current slide. Oh, there's another video here, which might be interesting. Let's see what this one is. I think this is another warehouse video. Yep. The carriages go up and down between the shelves on rails. You can see the antennas sticking out the back of this that tell you that it's the same box as that. This is a robot warehouse.
You can't use the sound.
Hmm?
You can't use the sound.
Yeah. Where's the... Okay, not a problem. There was a microphone, but it's gone. Yep, go for it. Okay, not a problem. So, that's this is another French warehouse system. So you can build this. You can build this for shops in Casablanca and Marrakesh and Rabat if you want to, and you can specialize in programming the machines, programming the trolleys, programming the systems that retrieve the stuff. Shall we learn robotics? Who's interested in learning robotics? 1, 2, 3. Okay. $200,000 a year? Is that you? Yeah? Have you got a wife? Are you married?
Yes.
Uh-huh. What would your wife say to you earning $200,000 a year? Ask her.
I have to ask my wife.
Yeah.
It's next to me.
Uh-huh. She's sitting next to you. What would you think of him earning $200,000? What would you think of you earning $200,000 a year? There should be no difference in pay between men and women. Okay, here is a simple robot that we can buy in the UK for £1,000. Okay, it's called a DoBot, and it can be controlled by one of those. And that's what you would use the very simple basics of robotics on to learn. So it can lift, it can turn, it can put things down, it can find its way out, it can move the arm and the head back and forth, and it can pick things up. So you can have a little business in developing hands for different tasks. Now we can add some vision, because here's a camera module, which is it's cheap to obtain. And cheap to program. Now let's add a conveyor belt. The conveyor belt, which goes with the robot, costs a couple of £100. but you can control the two together so that you can move the belt along at the same time as the robot is picking and placing things. So suddenly you start to see the basics of making a robot warehouse. Is this making sense? No? Oh, come on, clicker. And then we can add a sliding rail so that the robot, the doobot, can slide back and forth along this rail so it can pick things from that box and that box and that box and put them in that box. Okay? Suddenly you start to see all the basic skills you need to build a warehouse. You can see what you're doing. You have a conveyor belt going past you, and you can move the robot about. Now, all you need is a little vehicle which will go back and forth with the completed boxes. And here are some very simple robot vehicles. All they are is a battery with some motors and an extension which allows it to reach up and pull down. And that's all. And from that, you can make a complete model warehouse. Now, does that sound like a useful project that we could run at in Rabat? Yeah? It would cost about maybe £10,000 to build. £10,000 is easy to find. So all we'd need to do is to have a competition to see who should be on the team that builds it. Okay? We'd have to have a competition because we only want good people. People who are good at this and good at that and good at the other. So that's how you would build a robot warehouse. And suddenly, you have a mini version of this. And you'll have people from all around the world coming to see if they can hire you. There might even be some people from America would come and try and get you a visa. Okay? So those are very simple basic skills that we can teach you. So now you're saying to yourself, well, how do we program all these robots? Has anybody heard of the robot operating system? The robot operating system is an operating system that lives within the Linux operating system, and it controls motors and cameras and batteries and other things for use with robot arms and cameras and vehicles. So you use robot operating system within Linux with the Jetson pack that I talked about earlier, and you can make a complete robot system work. Does this sound like something you can learn? We'll do a workshop on the robot operating system over the weekend, over the next year, if we can find enough people who are interested. Okay? You can tell your friends, because we've probably got more room for more than 10 people. Okay? Lots and lots of software. You don't have to do research. All you have to do is pull the information in from the repos on GitHub and program it into the device. You can use a number of different languages. And remember, ROS lives on Jetson. So you put the commands for driving the vehicle on this side of the CPU, and you put the vision analysis on the GPU. So you can make this a team project with one team working on driving the vehicle and one team working on the vision systems. Oh, for fuck's sake. Now, because training real robots is downright bloody dangerous, because the robot doesn't know that you're standing beside it when it goes zzz, zzz, whack, and then you have a broken head. Okay? So it's very dangerous to just try these out without simulating them first. So NVIDIA provide a simulation called Isaac, which allows you to simulate the environment and discover what happens when you give it a series of commands. So you won't suddenly give it a command that says, gently pick this up, take it over there, and gently put it down. Okay? So this is all available. This is so new that even I can't get access to the development package yet. But you can sign up for it, and we will see what we can do about running classes. That's if people are interested. If people aren't interested in earning $250,000 a year, they don't have to come to the classes. Now, what platform do you need for all this? Well, to start with, you need a top-end desktop machine with sufficient power supply to support the GPU card. And I suggest you put an InfiniBand interface in to allow the PCs with GPUs to be networked together. Because do you remember I said that some of these jobs can take 4 and 8 hours to run? If you network 8 PCs together, all of them with GPUs in them, it'll take about an hour. InfiniBand provides the communication network for all these things, so you're in business. Anybody want to help build build a supercomputer? No? If you learn how to build supercomputers, you've probably got a job for the next 40 years. So the PC, top-of-the-range Linux machine, running Ubuntu 16.04 or higher. We let you know when we figure out how to make 18.04 work. You want lots of solid-state disk, hard disk core, and lots of RAM. If anybody's interested, we can provide you with the recipe, and we can set up a small specialist in building these PCs to provide a platform for students to work on. If you build your own, they come in at about 2/3 of the price of building them from a shop. If you buy, you've got a choice of GPUs to buy. At the moment, the GTX 1080 is what I have. There's an upgrade to that called Titan 5, which costs 2.5 times what I paid for my GPU, but you don't get the performance. Don't get the performance increase that justifies the price just at the moment. So you're probably better off with a GeForce GTX, and if you need the extra processing power, we can network some PCs together. Now these are the downloads. They're free downloads. Once you have got the computing platform, you can get the basic deep learning system development kit, which is a download which only takes about 5 minutes, and then you can install it. The trouble is that the instructions you get from NVIDIA at the moment don't tell you all the other packages that they assume you've installed. So you find yourself tearing your hair out at 2 o'clock in the morning, trying to figure out what's gone wrong. It took me 3 days to discover that they expected me to have installed secure sockets. But you get there in the end. You just sign up to the developer program and download it. DeepStream SDK is for analyzing video streams, so that instead of analyzing still pictures, you can analyze video streams. Now, what I'll do is, because I can't show you the Playtime on the machine that I brought with you, I'll show you the pictures of what you can expect from the embedded programs, the pre-programmed examples that are in the Jetson when you get it. And then there's the Isaac SDK, which we're still waiting for a release of. Now, the Deep Learning SDK, it's got a vast amount of tools and libraries, including machine vision, NVIDIA's Caffe version, Microsoft Cognitive Toolkit, TensorFlow, Torch, and many other systems. If you use the latest version, you can run it on their Volta machine, which is something like 10 times more powerful than the Pascal machine that I have on my GPU card. So these are very, very powerful processing machines. And this CUDA DNN, it's for deep neural networks. It's a library of routines for deep neural networks, so you don't have to develop all these things yourself. All you have to do is call the appropriate routines. DeepStream allows you to analyze video streams. You can pick out frames. You can pick out items in frames. You can track items between frames. So you could say he is moving from here to there, and you can detect thieves leaving shops and going into other shops in near real time. And we're still waiting for release of the SDK. My application is still waiting to be approved. Now, a do-it-yourself supercomputer. Are there any supercomputers in Morocco yet? No? Do you think you should need some? Yeah? Which university are you from? Uh-huh. Okay, what would you use a supercomputer for?
Something from Dell company.
Yeah, what would you use it for?
You use a simulation, electromagnetic field.
Yep.
And also for Monte Carlo simulations.
Yep. So if we can show you how to use 16 GPUs to build them into a small supercomputer, you can expand it by as many GPUs as you can afford. Each GPU is £1,000, so you can build yourself a supercomputer of 32 GPUs for less than £50,000. But you can build it in steps, so you do one step this year, one step next year, one step after that. And each step you can show the minister and say, please, can we have some more money? Yeah? And once you start and show people that you can build your own supercomputer, all of a sudden you get the wonderful Intel company showing up saying, please use our solution, please use our chips, please use our boards. We'll give them to you for free, and we will fly you to Walt Disney World or anywhere else you want to go. And please use our chips and don't use any of these GPU chips anymore. Okay, so there are all sorts of possibilities there. You can use them for medical image analysis. You can use them for geophysical analysis. You can use it for hydrography and models of the seashore and how the seashore is changing. You can use it for all sorts of things. But this would make, there are two ways that you pass information between clusters of GPUs. One is called the message passing interface, which is well known, and the other one is called memory sharing. With InfiniBand, because it's so fast, you have no lag as the messages are passed, so the whole cluster can work as if it's one single cluster. And you can benchmark your performance against other supercomputers by using the protein simulation program, GROMACS. GROMACS is used for simulations of proteins so that you can see what happens if you change the molecular structure of a protein. It changes the folding of it, which changes the biological interaction. These are all doable. People just have to tell me they're interested. If nobody's interested, I might have to go to Kazakhstan and build the program there. But the girls in Morocco are prettier. Don't tell the people from Kazakhstan. So the other thing you can do in order to train your students is you can build a GPU farm and put a cloud interface on it, so that instead of using the incredibly expensive Amazon Web Services to train your students to use GPUs so that they get really good jobs, and because they get really good jobs, you get more funding from the minister. Does that work? University gets lots of students, good jobs, the minister gives them more funding so that more students get good jobs. Does that work? Yeah? Doesn't work in England. You've got to be a friend of the minister in England. But you can build your own GPU cloud. So you can have a GPU farm, which allows people all over Morocco or all over the Maghreb to use your GPU farm through a cloud interface. So you can let them use 20 GPUs for very intensive computing, and then when they don't need the 20 GPUs, they hand them off and let somebody else use them. That is a feasibility study that somebody in the economics department needs to run. So, so really, that's there isn't a lot else. There isn't a lot more I can tell you. If I build a team, the trouble is there's only 26 hours in a day and 8 days in a week, and I've got to sleep for at least 2 or 3 hours a day. So I can't do all this on my own. So I need to build a team. But I can't have a team of passengers. They've got to be people who bring skills to the task. So I need to see how we will hire people who would be interested in building things. We'd have an evolving hiring plan, so that in the first phase we would need these specialists, second phase we'd need these specialists, third phase we need these specialists, and we build them all in, and we have a rollout plan all around Morocco. And we'd probably do the selection on the basis of hackathons. Do you know hackathon? Do you run hackathons here? The word hackathon comes from marathon, where you and a team arrive together. You're given a task, and you're told how long you've got to solve the task. The ones who solve the task in the target time get shortlisted. The ones who don't are sent home. You can give them one certificate for trying. They can come back next year. Would that work? Would that interest you? No? Everybody asleep? No? Donald Trump is in the back of the audience? No? Okay, run. Okay, so, right. How are you going to learn more? Well, this is the GPU Technology Conference in Munich, which is in October this year. Now, there's a big session on artificial intelligence and deep learning. So if you want to go and hear from people who know vastly more than me, because I've only scratched the surface of what we need to know, there's this big conference in Munich. Now, because it's in Germany, you can get visas. Okay, Germany is a very civilized country. And you can take part in this three-day conference and bring back lots and lots of knowledge with you and teach other people. You can choose from 100 sessions. You can find the information about it online. You can get training in a particular area that interests you. The cost is not wildly extravagant. If you sign up before the end of July, you get to participate for a very sensible price. You can find out all about it at this website. If you get, they have a competition for poster presentations. So if you have an idea or are running a project which involves GPUs, you can submit a poster like the one I have with me in my tube, which is about a smart city. You can submit that, and if you're accepted to present a poster, I know a professor who has got some money to pay for your travel expenses. So, if you would think about it, or we can try again next year. So really, that's all I have to tell you. Was it interesting?